Good day. On behalf of the Corrosion Inhibitors Joint Industry Project, I would like to welcome you all to the webinar series on precision in corrosion inhibitor selection testing for the oil and gas applications. The first right step. The objectives of the webinar series are twofold. As the title indicated, the primary objective is to promote a broader awareness across the industry on the need for developing standard test methods with known and published precision for the corrosion inhibitor evaluation and selection. We'll be talking more and more about precision throughout the webinar series. We'll also talk about the process of developing the standard test methods. Standard test methods includes the precision statements. The standard test methods do not get developed on their own, or it cannot be a one-person show. It requires collective, coordinated process. So the importance of collaboration among us and coordination is critical or essential in the development of standard test methods. Once we develop standard test methods, they will have huge impact in the industry best practices. So the first objective of the webinar series is to promote the awareness across the industry. The second aspect is to promote the joint industry project, which we have been working on for the last 3 years now, and almost all of us in one way or other contributed to this JIP. Currently, we are embarking into phase 3 of the JIP, which is the development of standard test methods for evaluating inhibitor efficiency and secondary inhibitor properties. Essentially, development of precision statements based on repeatability. We'll talk more about this definition of precision and repeatability a little later in this webinar. This webinar series, actually Trevor Place, who is the project leader of the joint industry project, and I discussed it, and we thought that we should talk about 15 aspects of precision as well as standard test methods. This is webinar number 2. Here we are going to focus on what are the challenges in harmonizing corrosion inhibitor testing, especially in developing precision statements. Even though the precision statement or the standard test methods are not widely used in the corrosion inhibitor selection in the oil and gas industry, they are being used as second nature for other mitigation strategies. So the focus is, let us understand the challenges and find solutions for them. Again, what are the drivers and motivation for this webinar series as well as for the joint industry project? If you look at the corrosion control strategies, if you select a good material, we won the war. Many times we use carbon steel. Carbon steel undergoes corrosion. So to protect carbon steel, externally, we apply coatings backed up by cathodic protection. For internal corrosion control, The time-tested and proven methodology is corrosion inhibitors. But if you look at the evaluation of these four strategies, for all three strategies, the requirements quantification is required in regulations, but not for corrosion inhibitors. For example, almost many regulations for material selection follow NACE MRO 175 or ISO 1556. For coatings, we have got very, very quantitative standards like CSA 24520 and of course NACE standards. For CP application around the world, everybody follows NACE SP0169 or derivatives of that one. For inhibitor selection, we have got only one standard, which is ASTM 202. Of course, we also have training on these standard test methodologies. And finally, if you look at the criteria for material selection, coatings, and CP are very, very quantitative. An inspector will come and follow the material to make sure that it meets the, for example, NACE MRO 175 standard. Quantitative criteria, if it doesn't pass, the material is not selected. Similarly, for coatings, one of the tests is cathodic disbondment test. For the fusion bond epoxy, the coating exceeds in the test more than 15 millimeters, the coating is rejected. For cathodic protection, the minus 850 millivolts versus copper sulfate is the quantitative criteria. If it doesn't meet, then it is considered that CP is not effective. However, such quantitative criteria are not developed as an industry, and that is the focus of this webinar series as well as the JAP project. What are the motivations for establishing the precision in inhibitor testing? We could continue to qualitatively evaluate using methodologies whose precision is unknown. However, down the road, if we were questioned externally, we might fail. As a matter of fact, we will fail. So we will crack under the external scrutiny. So we don't want that one to happen. We could wait for the regulators to impose things on us as they are done for green inhibitor evaluations for application in North Sea. But that could have some unanticipated consequences. So the motivation is that we as a leaders, owners, operators, chemical suppliers, and other stakeholders are in a best position to lead targeted development of quantitative consensus standards with known precision. Let us lead it rather than being forced externally. That is a motivation. You might ask why this quantitative evaluation matters. If we have a precision statement, as we have for other corrosion control strategies, it provides a uniform framework for comparing chemical performance across multiple suppliers. It provides a level playing ground so that all inhibitors, all chemicals performance are evaluated in a common ground. Once we select, it provides a consistent, defensible, verifiable foundation as to why we selected that chemical. So it provides an evaluation performance. The first two bullets are while selecting and qualifying corrosion inhibitors. In some parts of the world, they routinely monitor the quality of the chemical during application. Even for that one, the precision statement creates a defendable framework for monitoring inhibitor quality in ongoing field applications. Of course, we need third-party laboratories to evaluate the inhibitor properties. So even to qualify the third-party corrosion testing laboratories, the precision statement will help. So what is precision? There are two broad definitions. One by ISO, another by ASTM. Many times when we talk about precision, people confuse that one with accuracy. Accuracy and precision are two different parameters and they are interrelated. So let us talk about accuracy. Accuracy, according to ISO 57251-1, is how close a measurement is to the true value or accepted value. Let us break it down. In the last webinar, Dr. Winston Reevey talked about the joint industry project in which he compared the inhibitor performance in the laboratory versus in the field. So the field inhibitor efficiency is the true value to which the lab performance was compared. So that project evaluated the trueness, that is how close the laboratory values compared with the field value. That is one aspect of accuracy. Again, accuracy consists of trueness and precision. So the trueness was evaluated by the previous joint industry project that was completed in around 2000. Precision has a different meaning. It depends upon the repeatability or reproducibility of measurements. So this definition is consistent, precision definition is consistent all across the standards organizations. According to ISO, the precision is how close the repeated measurements are to each other, regardless of whether they are close to the true value. So the precision statement talks about the repeat values we obtain when we repeat the test. It does not talk much about true value. In other words, when you are talking about precision of laboratory methodology, we are only focusing on the repeatability and reproducibility. We are not comparing the lab test with field test. That is accuracy portion of it. ASTM, on the other hand, gives little more direction. It defines what is repeatability and what is reproducibility. Repeatability is a measure of one person, one laboratory to produce results using same apparatus, same condition, following the same procedure. So one person doing the test, the variation he gets or she gets is a measure of repeatability. Reproducibility, different persons, different laboratories across the world to produce results using similar apparatus, same condition, and following same procedure. So repeatability, one person, reproducibility, different persons. ASTM requires data point from 6 laboratories. So in our JAP or in our discussion, we are going to first focus on repeatability in terms of defining precision. Having understood the importance of precision, let us review what are the challenges we have in establishing precision. The first challenge is that we have been using corrosion inhibitors for almost 75 years now. And a long period of time, we dependent on the current evaluation practices. And in our industry, change is difficult. We have to agree to that one. So how does the precision provide a solution? We are not going to drastically change how the industry works, but promote the fact that understanding corrosion inhibitor efficiency under standard conditions using methodologies of known precision serves as a reliable starting point. The focus is starting point. If you have standard conditions with known precision, whether, as an example, Frank at Corematrix does the experiment in Calgary, or somebody does the experiment in Australia, they should be getting the same results within the precision. So that gives us a good, reliable starting point. Let us also review some of the challenges from the operator's perspective. We'll also talk about the solutions. One constant feedback from operators is that, hey, our operating conditions change continuously. So we cannot do one test. True. But if we have a precision statement, it provides insight into inhibitor performance across various operating conditions. For instance, we have what is known as integrity operating window. In integrity operating window, we need not have to worry or we need not have to react for every change in the operating condition as long as the operating conditions are within certain operating envelope, then we can consider that the operating conditions are stable. Again, integrated operating window is promoted by API 581 standard. So having a precision statement helps us not to react too much for the changes in the operating conditions. The second challenge for the operators, hey, I don't have much time to evaluate and select corrosion inhibitors. We are busy with so many other things. So we normally depend on vendors' expertise to provide quick solutions when we need to select a chemical. Good practice. But the precision statement helps supporting informed vendor selection. And more importantly, it provides a pre-qualified list of chemicals. So we don't have to start from the scratch, but we can start from well-established precision statement based on standard solutions, standard conditions, so that we can easily pick chemicals from a list of chemicals. Some of the operators, when you talk to them about this JAP or the precision, the answer is, or the question is, why bother now? We have been living like this for the last 75 years. Why bother now? Well, it helps to strengthen the company's position, especially when engaging regulators and insurance providers. Just before the webinar, I was talking with Frank and Bud, and I started involving in this project for almost 32 years ago. And at that time, I also got the driving license in Canada. When I went to the insurance provider, the first suggestion he made was to give you insurance, you have to undergo training, and of course, you have to pass the road test. It's a standardized training. If you do the standardized training, it's a 3 hours, a 3 day theoretical class, then your insurance price will go down by 50%. So this is one of the major drivers in precision solution. If the insurance providers start suggesting for precision, that will be a good driver for the precision, and precision solution will help to reduce the cost. Now let us see the challenges from the supplier's perspective. Suppliers live on inhibitors for a long period of time, but their main challenge is that sometimes the operators may not provide complete operating conditions. Yes, that is true. But if you have precision, then you can at least establish how the inhibitor performance will be within the operating envelope. So every operating change does not trigger into inhibitor evaluation as long as we know the precision statement. Precision basically gives us an envelope, a bracket under which the inhibitor performance will remain similar. So it provides insight into the variations in inhibitor performance when operating conditions change. The other challenge for the suppliers is that they normally are forced or encouraged to follow tests requested by the operators. Though in some cases, that test may not be varied for the specified operating conditions. This is one of the major challenges faced by the suppliers. Of course, precision statement provides an informed test selection along with the joint industry project phase 2 outcome, which gives a flow chart as to which lab methodologies to be selected under what conditions. Along with precision statement, this addresses some of the concerns of the suppliers. And let us also talk about the reality. Why do we do the testing in the first place? Obviously, we have to win a contract with a owner. So we do lab testing under the instructions of the owner operator so that the supplier's chemical is qualified and it wins the competition against other suppliers. So this is a reality. We cannot overlook it. So the inhibitor testing is not only technical, but also it's a marketing tool. But if you have a precision statement, it strengthens the competitive positioning of chemicals within the level playing field. In other words, if all the chemicals of some of the chemicals fall within the precision range, then all the chemicals can be qualified. Then price comes the criteria. Hence, the precision statement will provide a level playing field for the chemical suppliers. Again, in the webinar number 1, we gave a very clear table comparing how the precision statement helps us to narrow down chemicals in terms of cost. Now let's talk about the third-party laboratory perspective. What are their challenges and how does the precision solution help? Third-party laboratories, they specialized in specific laboratory methodologies and they have developed expertise in them. That is why we rely heavily on the third-party laboratories because they have the lab and apparatus ready to go when we need them. The precision solution provides insight into the inhibitor performance across different laboratory methodologies so that we can pick and choose the laboratory, third-party laboratory with known precision so that that laboratory got pre-qualified. And we can also tell the third-party laboratory what particular laboratory methodologies to be used instead of they choosing them from their specific experience. In the industry as a whole can give some guidelines. If we have to make a new laboratory methodology, third-party laboratories, they may not have budget or intention to install new methodologies unless they find a funding solution, funding source. Unless there is a client, nobody wants to develop any new methodology. But the precision solution support establishment of several third-party laboratories operated by multiple stakeholders because the precision statement gives a step-by-step procedure not only to do the testing, but also to develop the lab methodology along with the precision statement. So this provides, it helps the industry to have many third-party laboratories. Some third-party laboratories are very, very open. They let the clients come and inspect the lab testing as they progress. But some laboratories are very conscious. In fact, Trevor Place once explained that one testing laboratory did not allow him to enter because their procedures are proprietary in nature. And it was one of the triggering points for Trevor Place to support this joint industry project so that we can understand that we can overcome the proprietary nature of a third party, and the precision solution can provide a level playing field for all participants and helps to prevent monopoly practices. And I had an opportunity to visit many of the laboratories in many parts of the world. Most of the laboratories welcome and they educate me as to how do they carry out their testing. I would like to particularly shout out Frank Cornbatrix. Whenever I call him, he always invites him to his lab and he provides all this information that I'm looking for. I would consider those laboratories are unique, but some laboratories are kind of very, very protective. So we have to overcome that as an industry. Let's also talk about some general issues around harmonization. Some labs, they have sophisticated flow loops and their expertise is well established. If you have a precision statement of the benchtop laboratory methodologies, it enables operators to determine whether to use a flow loop test or a benchtop small-scale lab testing will be sufficient. When ASTM looked into developing standards into around 2000, they looked into developing standard for flow loop, but they did not go for it because every flow loop is unique, proprietary, and that cannot be repeated or reproduced in other locations. As a result, it does not play a level playing ground. And during the several interviews I conducted, one of the owner operator explained that They extensively use flow loops for their inhibitor testing, and they pay 40,000 US dollars after each flow loop testing to clean and and replace many parts of the flow loop. So flow loop is good, very sophisticated, but it can be very, very costly. Many times a benchtop methodology is more than sufficient to evaluate corrosion inhibitors. This may not be a statement with respect to North America, but this could be a fact in some part of the world where they do not have access to an adequate number of compatible laboratories, nor their government policy does not allow them to access laboratories abroad. This is unique in many of the countries outside North America. Establishment of precision provides a level playing ground. It facilitates establishment of standardized test solutions across the globe. In general, one of the issues is that cost of testing is high and it varies considerably across laboratories. I will explain in the next slide. The precision solution supports development of consistent cost estimates. This is in real data, not for corrosion inhibitor evaluation. I was involved in two different projects. I was asked to coordinate lab testing, not for corrosion inhibitor evaluation, but for understanding another corrosion control technology. For one, there was no standard test methodology, and I approached 6 laboratories to provide a quotation. You can see that when the percentage quote from 6 laboratories can vary extensively. In one lab, they quoted, believe me or not, 1,000 times higher than other lab because of the non-standard nature of the lab methodologies they use. In another project, I requested quote from 3 labs to conduct their test under standard test methods, and the quote came almost closer to one another. So this is the indirect benefit of having a standard test method with known precision, because the procedures are constant or established, precision is established, lab methodology is established, everybody does it consistently. As a result, the cost becomes consistent across the world. So in summation, the precision statement establishes a framework, a uniform framework for comparing chemical performance across multiple suppliers. It provides a consistent, defensible, verifiable foundation for evaluating performance. It provides a defendable framework for monitoring inhibitor quality in ongoing field applications. Of course, it helps to qualify the third-party laboratories. With that, let me quickly go through some highlights from phase 3 of the JIP. Again, I would like to thank both sponsors as well as non-sponsors for bringing us to this stage. We had 11 sponsors. Most of them are continuing for phase 3. And we also had lots of non-sponsors who provided inputs, guidelines, and data to define the scope of the JIP. Right now, we are in phase 3. Our focus is to develop standard test methods for the most promising and popular methods identified in phase 2. And we have identified 8 lab methodologies for standardization. The official kickoff meeting with the sponsors will be next week, December 2nd, because we have got enough sponsors to kickstart phase 3. Again, as I explained in the previous webinars, In the oil and gas industry, we use corrosion inhibitors under different operating conditions. With respect to inhibitor selection, evaluation, and application, the JAP classified the oil and gas industry into 23 applications. And inhibitor performance requirements in each one of the applications is different, unique, and that has been well established in phase 2. So considering these 23 applications, we have established 8 methodologies. If we standardize them, that will have a huge impact in all the 23 applications. Again, when we are talking about standardization, we classified or categorized the inhibitor performance tests into 4 categories: screening test, selection test, special test, and secondary inhibitor properties test. Screening test is within the scope of phase 3. Normally, we carry out screening tests for shorter duration under standard conditions. This can be used by chemical suppliers, owner-operators as an economic means of developing a short list of chemicals from several chemical suppliers. Step 1. It is also being used by owners and operators to ensure quality of chemicals at various frequencies during operation. So our focus is on screening test in terms of standardization or to establish precision statement. Selection test is step number 2, where from the pre-selected chemicals, the owner-operators will carry out long-term tests simulating as close as possible the field conditions. Because field conditions are unique, we cannot standardize them. That's why we are focusing standardization only on screening test. The normal screening tests are good for evaluating general corrosion as well as splitting corrosion rate. We need to use special tests to evaluate efficiency of corrosion inhibitors to control unique corrosion mechanisms such as under-deposit corrosion and top-of-the-line corrosion. So these tests are also fall under screening test category, and they are considered in the JIP as special tests. Secondary inhibitor properties are unique for each one of the operating conditions, and some of the secondary inhibitor properties needs to be standardized, and they are within the scope of phase 3. Again, the benefits of screening tests, we put a slide together because this is a kind of not well established, not well understood across the industry. Yes, screening tests are short term, but it helps us to compare efficiency of multiple chemicals under identical conditions. This provides a level playing ground to select chemical vendors as well as chemicals. It also helps us to verify the quality of selected chemicals during operations. In some companies, they do regularly monitor the quality of the chemical that is being supplied, for which they need a quick test, and screening test is the most effective one. Of course, some operators will prefer selection test if they can do longer term test, but many operators requires screening test, and hence precision of screening test is important to establish quality control. Sometimes people do not wish to differentiate screening test and selection test because their feeling is that the test should be conducted under the field operating conditions. But let us go back to the fundamental. An inhibitor, if it is effective, it forms a surface layer on top of the metal surface. That is a fundamental requirement of a chemical that is to adsorb onto the surface and control corrosion. So for which the inhibitor should perform well both in the screening test as well as in the selection test. Of course, the efficiency of the inhibitor under the harsher screening and under the harsher selection test may be lower, may be decreased due to the weakened adsorption strength. But understanding the efficiency using the screening test will give a good quantitative value as to what is the maximum efficiency of the corrosion inhibitor, what is the maximum strength of adsorption of the chemical on the metal surface. So that is a major benefit of doing screening test standardization. It gives us a good starting point. Of course, it also helps us to qualify the chemical vendors. With that, we have established 8 methodologies. And in this webinar, I'll talk more about the 1 liter rotating cage, and other methodologies, I'll talk about it in future webinars. Some companies are using 1 liter rotating cage. ASTM, when they coordinated a round-robin test in around 2000, which involved 10 laboratories across the world. Many of us are in attendance in this webinar. They use 7.2 liters rotating cage. A precision statement was established almost 20 years ago. However, 7.2 liters volume is relatively large and therefore is not practical for routine use, especially for quality control and quality assurance. For which nowadays, some companies are using 1 liter autoclave, 1 liter rotating cage. And I had the privilege of visiting some labs which use 1 liter rotating cage, and they have their own apparatus, number of coupons, configurations. Some companies use 1 coupon, some companies use 2 coupons, some use 4 or 8. But that is okay. But the problem is that, or the issue is that they claim that they follow ASTM G202. Again, when we say standard test method ASTM 202, it requires specific apparatus, specific procedure, specific operating conditions, specific configuration. If you change any one of them, then you have to redo the precision statement. That aspect is not understood by some of the laboratories. To address that one in phase 3, we are going to standardize the 1 liter rotating cage under standard condition, and we establish the precision statement for that geometry and for that operating condition. In that process, we'll consider the flow characteristics, corrosion rate, number of coupons effect, geometry of the coupon effect, as well as the aspect ratio between 7.2 liters autoclave, 7.2 liters rotating cage, and 1 liter rotating cage. So that way, we have 2 separate standards, one for 7.2 liters and one for 1 liter, so that the precision statement is established and can be routinely monitored. In terms of deliverable, in phase 3, we will give step-by-step procedures to carry out all lab methodologies under standard conditions. We will provide blueprint of all new laboratory methodologies that are going to be standardized, new methodologies rather. We will also establish solutions, standard solutions, and procedures to prepare them. In one of the webinars, we'll talk about this aspect a little more thoroughly as to why that is important. The major deliverable is the precision based on repeatability of lab methodologies. That will be standardized in phase 3. Again, precision statement will be established based on repeatability, and then we'll coordinate the reproducibility afterwards. Again, this is the sponsorship fee. I'll skip that one for the time being. With that, let us open the floor for discussions, challenges, question and answers.